to a robot adventures helpful video. Come back. Children, do not watch this video. This video is about my 3D printer, and hopefully I'll make 3 videos to help people new to the DIY build-it-yourself 3D printer kit stuff. A lot of this information you can find on your own if you go to different websites, and you watch a lot of the other people making videos like Tom. He's very informative. I watched him a lot. And after watching a lot of that and figuring out, oh, this is this and this and this and this and this, it's like, oh, okay. Well, you know, once you start getting into this 3D printer stuff, you just get tons and tons of jargon thrown at you, and if you're new to it, it's like, wow, it can be overwhelming. So hopefully this is just for the beginner stuff. You don't have to get into the firmware. You don't have to do any soldering. You don't have to know much about electronics, but I will show you how to do that with that. And just to get your printer up and going. So I did mention in the video, I talked about how to set your potentiometer using the voltage reference and how to do it by ear. I didn't show how to do it on the firmware because I think that's a little bit more advanced, but you can set it up without getting into the firmware. And I talked about the reference voltage, what to set your potentiometer screws, what voltage to set them to using the meter, and where to get that information. Where you get that is, of course, from the data sheets from Polulu. And but for the Flying Bear people, there are 2 different equations depending on when you got your chip or when the chip was made, and which chip you got with your Flying Bear, or you know, for anybody using these drivers, stepper motor drivers. You can see that they changed the equation depending on, starting this year they changed it. So I'll talk about that, and yeah, I think that's pretty much it. If you have any questions, well, you know, maybe I answer them later in the video. But yeah, you can go around and look at a bunch of other videos, or just, you know, I think I cover all of the wiring stuff in this one, except for getting into the firmware and writing code. I don't do that because that's not for beginners. Alright, so yeah, hope you enjoy. Any questions, leave them down there. Kampai, bye-bye. Alright, so this is part 1. The wiring video. Part 1 of 3, hopefully. And there's going to be 2 parts to this video. Part 1 is where I talk really fast about all this stuff, and then for the impatient people. And part 2 will be the part where I explain what I just said, for those of you who want more detail. Alright, so you set up your board. You got your power connected right, and you got it all hooked up on whatever printer you got. This is the Flying Bear P902, if I haven't mentioned that before. And mine doesn't actually look like the Flying Bear P902 because I've changed these stepper motor drivers from the Polulu A4988s to the DRV8825s. So one of the big problems is that usually when people set up the stuff, they're ready to go, follow the instructions, and they're like, okay, go, and it doesn't work. So it's like the filament isn't coming out, or it isn't moving, or something like that. So they're kind of like, oh, that kind of sucks. They're all pissed off. Let me swap out something here real quick. The problem is maybe with the, well, if you haven't got something in reverse or something like that, or something isn't connected, or something's broken, or if that's not the case, then it's probably your stepper motor. Maybe your board's screwed up or something. But so all of the Flying Bears, at least as of whenever I got this in 2007, came with these A4988s. And you can see the potentiometer is on this side, and the DRV, it's on this side. Well, how do you know that? It's because the little tiny writing on the boards tell you where the ground is and where the pins line up. So if you read the little tiny writing on the boards, you can set up which way they're supposed to go. Maybe you had your drivers flipped in backwards or something, and that screwed up something. So and really quickly, to set the correct amount of voltage, current, to your stepper motors. Oh, great! Well, there's a stepper motor over there, and you have to use if you want to do it according to the specifications, you can use the voltage reference to set these stepper motors potentiometers at a certain voltage, and that voltage will send the right amount of current to your stepper motors. And what is that number, Ruben? Well, it depends on your stepper motors, right? So if you have like a small stepper motor that requires 1 amp, then you maybe need less. If you need another one, like the ones that we have, let me just show you here. Oh crap, I don't want to break anything. Like this one requires 1.5 amps. So you need to know that and put that number into part of the equation to get the reference voltage to set the voltage and make sure that your stepper motor is getting enough current, amps, to function correctly. Yay, okay, so that's what we need to know. And on this Flying Bear P902, the Polulu data sheet equations show that the DRVs 8825s require the amp, the current is equal to the reference voltage times 2. So that means whatever your amperage is, the amps that you want, you just divided that by 2, and then you'll get the reference voltage reference. So if you want 1 amp, you'll divide that by 2, and you get 0.5 millivolts. So there you go. If you're using one of ours, like a 1.5 amps, then you'll get like 0.75. And come by. And that reference is set to 70% of the max, or the rated current for your stepper motor. So you've got the 70% little bit of safety margin there built into that reference voltage. The A4988s, the ones that come with the Flying Bear, require a different equation to get the reference voltage. And what makes it even more tricky or annoying is that autofocus. No, why would you? Oh, because I want. Okay. Oh, yeah. Is that there are two different models or different models of these A4988s, and depending on the model that you got, I think as of January 2017, they started using a different component on the stepper motor driver, which changed the equation. And before 2017, and if you go to the Pololu website, you can see what they've done. And because maybe these things are copied by other people or stamped out somewhere else, I don't know what parts they're using. So the old equation was the current amps is equal to 0.8 times the reference voltage times 0.050, and that was the old equation. And you work that out, and maybe I'll write that up there. You divide, or you shift, you figure it out, and it comes out to about a 0.6. 0.6 is your old reference voltage on for a 1.5 motor. And there was another number, and then that's set 70%. If you want to kick it up to like 100%, then that's yeah, that was like 0.84. I think that's what the maximum on these A4988s was, and that's I think at 1.5 for a 1.5 amps. The Vref was 0.84. That's disregarding the 70% figure. If you have the newer ones, I think you can go even higher than that, and I think you're up at around 1 point something, but you can do the math. I don't remember off the top of my head what that was, but yeah, so, and if you have a different stepper motor, you're going to have to do the equation for whatever amps you want. So that's not a number that I know. And like I said, is some stepper motors don't require that much. They don't need to overcome that much torque, so they don't need that much power, and they can run cooler by turning down the amount of power going into them. So you don't need to set them that high and run. You can run the stepper motors cooler and maybe save, make them last longer. But a stepper motor costs like $10, so I don't know if you're willing to spend $10. I don't know if $10 is a lot. I don't know. So that's that. And you can set all that stuff. If you're you already know all this stuff, and you probably already have all the wires and all this. If you already know this, then why are you watching this? But So now you're like, okay, well, how do I set these potentiometers, these little screws, to the correct voltage reference? And how do I figure out the voltage? And how do I figure out which way to turn the screws, and if I'm fucking it up or something like that? Well, that's a good thing, and that's a good question. Also, if you're going to be swapping out your stepper motor drivers from the default A4988s to the DRV 8825s, why would you do that? Well, because and this is just an optional thing, and it maybe cost what, $8, $10 to get a whole set of DRV88s, 8825, so it's not that much. These A4988s, they have a 16. They can 16 micro stepping. And the other ones, these DRV 8825s are 32. Did I get that in there? Are 32. So they're an extra half of the micro stepping. Maybe that's better. But since we got a flying bear, we got this little extra fan, so you're going to be cooling these things, so that's kind of good. You want to make sure your stuff is cooled down, and because you're going to be running a lot of power through there. These little ones here, these don't get as hot because the voltage is less. It still works. It all works, but yeah, I don't know. It's an optional thing you want. Okay, so now to part 2, where I start explaining all the stuff to get in more detail. So there are maybe two ways, or maybe there's another way. 2 or 3 ways. I'm just going to say 2 because the third one I just make it up, pull it out of my ass. You can set the voltage reference on these things if you have a way to check the voltage. And, well, where's the voltage checking thing? Yeah, that's something that you don't get when you get your flying bear. So you're going to need one of these things, and this is like a multimeter. And this thing will check your voltage, and it will tell you a number, and then you can adjust the potentiometer, adjust these little screws here to get the number that you want. You just adjust it and use like a ceramic screwdriver or something, because you don't want to be jabbing metal in there, scraping stuff. So yeah, so you can use this multimeter, or you can figure out the voltage by ear. And a little bit of warning before you start twisting stuff: there is a limit to how far these things will twist. So you don't want to like keep screwing it until it pops out, because then maybe you're fucked. So don't screw it until I'm just screwing it this way. Don't turn it full, like 5 turns or something like that. Wherever they are right now, just leave them right there, and then you're gonna be just a little tip, like a not an eighth, like a quarter of a turn. That's a big ass turn. You're gonna be like 90 degrees. You're gonna be like at 93 degrees, and just the tiniest of turns is enough to change the voltage on the stuff. So there are two points. There's a range. The top range is when it has too much current, and the stepper motor will go into thermal overload. And that means it's got way too much power, and it's like, and too little power. And when you request the stepper motor to do something, it'll be like, and it just doesn't have enough power to turn. So if you're going to do it by ear, you're going to turn the potentiometer so that it gets to the point where it starts like, oh wow, that's too much, and then you're going to back it off. You're like, oh, that's too much power. It's going womp 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 womp, and then back it off. Yeah. So that's the way to do it by ear. And adjusting the potentiometer. Where did it go? These A4988s. If you turn it to the right, it gets more power. If you turn it to the left, it loses power. So that, I think that's the way. I could be wrong. I'm going to have to double check that. But these DRV8825s, they are the reverse of that. And you'll also notice that they are, the potentiometer is facing this front end over here where all the wires are. So the position of this thing is a little bit backwards, and the weight of increasing and decreasing power is also reversed. So I think this one, if you turn it to the counterclockwise, it increases power, and you turn it clockwise, it decreases power. And we're going to find that out right now, because I'm going to actually show you me adjusting the potentiometer and trying to set it back at the default 70% of what the required 1.5 amps for the motor is. Yay! Alright, wow, that was a long time. That was about 30 minutes, 40-minute video. Alright, so I'm going to have to stop the video and get all this stuff set up and ready to go. So, alright, I'll be right back. Alright, so I was editing the video and I realized I didn't show the way to adjust the potentiometer by ear clearly enough. You have to move the stepper motor using your display, and then you keep moving it here and adjusting the potentiometer over there. You can do it this way. So notice the name of my printer, Omega Magnus. And so you go here to prepare, and you scroll down to preheat, no, keep going scrolling down, to cool down, no, to switch power up, no, to move axis. Yeah, that's what we want to do. We want to move the axis. And we're going to move it by, let's say, one like that. Okay? And we're just going to move the Z. Move the Z. We can move any one, but we'll just move the Y. And you'll see the Y start moving there. Oh, there it goes. It's moving. The whole carriage is moving. And it just positive and negative. positive, negative. So you're doing this and you're adjusting the potentiometer until it has too much current or not enough current. If you're running it at too much current, you're gonna make the stepper motor get really hot because it's got too much power. And if you run it at too little current, then you'll be missing steps because it doesn't have power to turn the motor. And you can do all this without a multimeter. You're just doing it by ear and just guesstimating where is a good range. So you want to get it like between the top where it's like too much power and the between, or maybe 60% or whatever you think is a good range there. Between too much power and too little power, put it maybe halfway there, a little bit above that. And without the voltage multimeter, that's the way to set your potentiometer. Alright, now back to using the voltage meter. Yay! Multimeter. Alright, so we're going to use this multimeter here. And, yeah, what is this thing? That's a big thing. Yeah, and I'm not a multimeter expert. And I couldn't tell you why the other one is better than this one, but after watching some videos on YouTube, you got to get an auto range one, and the multimeters can run around like $300 or more for the professional grade somethings, and you can get really cheap ones to check your battery and stuff. So there's a huge range of multimeters, and why did I get this one? Because it's got the 4 spots for the leads, and it's up to 20 amps here, and fused. So I know that we've got, at least on our Flying Bear, a 20 amp power supply, and I liked this was on the reviews on this was on Amazon here in Japan for around 3,000 yen, which is about $30, and the reviews were pretty good. So this is the Peak Meter PM18C, and it's got this little dial on there. And a lot of the, electrician guys are like, oh, it's got a dial, you got to turn a dial. I like turning dials. I want to turn a dial. Oh, it's just so fucking inconvenient, you got to turn a fucking dial. Alright, well, shit. You just pay $200 for something you're going to use maybe twice or, 3 times. So, something like this is okay, I think. And we're going to check, since we're going to be in millivolts, and we're going to go, I think the max we can go is, I don't know if you can see that. The max we can go is around 1 volt. So this 600 millivolts is the top it will go. So we need to get above 600 millivolts. So we want to get to the 6 volt one. We'll go to the second unit, so we'll turn that dial. Yay, turn the dial. That's just live. We are live, man. So that's I see a decimal place over there, next to that 2, and oh, there you go. We're right there. The decimal place is right there. Volts. We're at volts. And we're going to be at point something. 1 is up here, right? 1 and then plus something. So we got to connect the leads here. This is the ground, and the juicy over here, the red one. So we'll connect that, and then we'll touch we'll touch the potentiometer and this little black cable up here that it has the ground, and we'll check the reading and see what it says. So let's connect that up. Alright, so here we are. We've got the leads in there. The red one goes to the red one, and the black one goes to the black one, and we're at the 1 volt up to 6 volts. It will register. And oh, I don't even have this thing plugged in. So, well, that's okay. So we're going to touch the black one here. This black, where's the little wire? Here's the black one and this red one over here. And we're going to touch this little black screw right here. This screw, yay! Screws. And touch that. And then with there's no power right now. And touch this one over here, the potentiometer. Boop, like that. And once you do that, there's going to be a number. I'm going to do that, but I can't turn the camera because I'm using 2 hands. I've only got 2 hands. I can use another organ on my body and like wrap it around like a possum and then move the camera. But then I might have to do something else. Hey, what organ are you talking about? I'm talking about my brain. That's what I'm talking about. But then a number will appear over here, and then it'll say, oh, that's the number. That's the current going through that, and this is XYZ and the extruder, right? XYZ and extruder. So you'll see how much current is going through there, and you'll be like, yay, that's the number. And then you'll adjust the potentiometer up or down, left or right, and that number, this number will change, the voltage will change, and then you'll be able to figure out how much you want, more power or less power, or something like that. Alright, so I've got to actually plug in the printer so that I can get some power going into the printer. Okay, so hold on. Alright, so for the Flying Bear P902 people, we did get a thing like this. We got a little with the ground on there and some wires like that. I was like, oh, okay, well, then you had to connect those wires onto your power supply, and yeah, I thought these wires were a little bit small, and this cable seemed a little bit thin compared to like the computer cables that we all have for a computer. So what I ended up doing was going ahead and picking up one of these switches, because we didn't have a switch to turn on or off the computer, the printer. And what I did, I had a power strip over here that has a, where's my finger? There, right there, that little orange light, that's a on and off for the power strip. So I had my printer connected to that, then I can turn it off, on and off at the power strip. But then I actually connected it up to one of these, and then I had 2 on and offs. So so that's what it's connected to now. And yeah, on these little things, and these switches, you can buy the. I recommend these things. They cost like $1.50 or something like that, and maybe go to the hardware store and buy another one, because or get it one wherever you're at, because it's just a convenient than pulling the plug every time. So, but it could be dangerous, very, very dangerous, because you're playing with wires and stuff like that. So that's why I have 2 switches. I have one to kill the power there and one to kill the power here. So if I'm doing some wiring, I can turn on and off the power supply here. But if I'm going to like start disconnecting stuff, I also turn it off over there, just in case, so that everything's turned off, and or you can unplug it. But yeah. So yeah, let's so the power's connected, and I'm going to touch those things, and let's turn it on here. It's turned on. You can hear the fan going. It's, hey, I'm alive. Yay. And we're gonna take these and touch the places where I showed you. Show me where you touched it. Right there. That one goes touchy right there, and this one goes. Oh, and the potentiometer is working. So I'm touching those two places, and I'm going to show you. I'm going to touch them again, but I'm going to show you what changes over here. So I touch the negative, the ground there, and touch the potentiometer. This is on the X. So you see that's 7.6. Okay, so that's around 7.5. And here's X, Y. There's a Y. Okay, that's Y, 7.58. This is Z, 7.4. Because Z doesn't really need that much power. And extruder, there's a little bit more power. Right, okay. So you can see that yeah, those are the references, voltage references. You just put it in there like that and touch that like that. Okay, there. And it says 7.6. Okay. So remembering X, this one was autofocus, come on. X was 7.6. Well, yeah, 0.76. I don't know. Oh, here you go. Come back. Yummy. So I'm going to take a screwdriver and I'm going to turn this little potentiometer to the. I'm going to turn it counterclockwise. This way. Counterclockwise to the left here. I got to just stick it in there. Just turn it just a little bit. Just tiny little. There. I just turned it that much. Did you see it turn? Almost nothing. And now let's check the voltage on there again. Black over there. Oh, you can see. Okay, well then point the camera down at the voltage here. Oh, I turned it to the left and it went up to 7 point, almost 2 points. So, in these DRVs, turning it to the left counterclockwise increases it. So here we're going to turn it to the right to go back to 7.5, 7.6, whatever. And this is X, so X doesn't need that much power, I don't think. So if we can go around 7.4 or something. Get that little screwdriver in there. Turn. Oh, there it goes. Locked in, and I'm just guessing. I turned it about maybe 1/8 of a turn. Maybe I turned it too much. So now I'm gonna touch them again. I'm not gonna actually show you, but I'm just gonna read out what it says. Oh shit. That was way too. That was 5.6. So I turned it way too much. So now I got to go back. So turning it, I turned it about 1/8, and that was way too much. So now I got to turn it back, power, and try to get it back to 7.6. So I'm gonna do that off camera because it's kind of pointless. All right, so that should be your setting up your potentiometers and your voltage using the voltage reference, and you can try doing it by ear. Just kind of, you got to find the point where it's too much on this, and then find the point where it's not, and I don't know how much of a turn that is, and then you're set to go. And if you, the problem doing it by ear is that you might crank it up too high, and it might be working. It's like, yay, it's working, but maybe the current is too high. And maybe you'll wear out your stepper motor faster. I don't know. So maybe getting a multimeter down the line might be a good idea if you can find one online or get one from a... You don't need one at the beginning, but it might be something to consider picking up. Maybe at a pawn shop. They probably have some there. Or your friends. Get your friend, oh, hey, Billy, come over here with your multimeter and let's check my printer. Okay. Maybe give them one of these or a little bit of that action for the help. You know, maybe the shocker. Could be helpful. Whatever Billy wants. Or Jimmy Bob. Or Susie Q. They'll be helpful. And yeah, I think that's pretty much it. So I'll try to post and this is the way it's set up. You got the ground pointing this way and the red wire pointing south. You got your two thermistors, one for the bed, one for the hot end. You've got your 3 end stops here, and on the Flying Bear we've got the 2 heaters for the hot end, the 2 heating for the bed, and those 4... fuck. That was really helpful. You've got the 2 for the hot end. You got the fan right there. You got the 2 for the bed. You've got the 4 going to your power supply, and these little wires coming in for your fan down here, and this will of course going to the fan on your parts fan on the carriage. So not that much wiring on this thing. And if you're wondering what all these little blue stuff and stuff are, those are little crimpy things that I went ahead and bought because I didn't like the way the wires were kind of all over the place. So let me show you this. We've got this thing soldered up. This is another bed, and the Flying Bear guys sent me this bed because my bed was a little bit warped, and I sent them a message and said my bed was warped. They're like, oh, boom, another bed. And here, where's the... I can do it down here. This is well, this here with this little sleeve that comes on there. You just put that little sleeve on there, and then you use a crimper to smush that down. So you can pick up something like this, these little ends. I think this is like 800 of these for like $10. So this was off Amazon, but yeah, it's just ends, wire ends, and you just find the right size that fits your wire, and you just put it on there. And then you need a crimper, which is something like this. And this is Iwis, I think a European brand. And there are different types. This is like a hexagonal thing, but they do make like square shaped ones. And you put the thing into the crimper like that, but I got a lot of wires sticking out there. And then you just smoosh it down, and it's got a little ratchety effect, so you crack, and then once it's crimped, yeah. So I ended up Yeah, I did that one right there, and that's okay. That's on there. And I did that for all of those, and yeah, for those. I think the black was. See, I did these at a bigger gauge. The blue ones are a little bit bigger because I had twisted them and I didn't want to cut the wires. But these ones I kind of did like that. And I probably should maybe cut them down, chop them down a little bit so that they stick all the way in there. Probably a better idea. But since I had to get the fan in there, I didn't. You know, it's like I'll make a little space. Yeah, that's what I did with that. So, the fans, those use these little black things here. These little black, ends on the wires. Those are called, DuPont, connectors. And there are a lot of different types. Here's a bag. I bought a bag of these. Oh, well, I didn't buy a bag. I bought a bunch of them, and they come in male, female types. You can get them already assembled like this, and yeah, you got the female type in there. Females are like females because they have innies, and boys are outies. So these are the male types. You can get male on male, which is very popular, and you can get like female and male, which is kind of whatever. And you can get female on female, which is also very popular according to videos and stuff. So, yeah. What kind of videos are those? Those are special kind of videos. And if you're gonna get those connectors, you're gonna get like extra wires and stuff to connect onto your ramps board. Well, then you're gonna need these DuPont connectors or something like that. And if you're gonna start crimping, then you're gonna need to get yourself like a crimping tool to do all the connectors, and then you're gonna crimp that on there and stuff like that. Another thing for the wiring. You'll probably need a wire stripper, and something like this is enough for your basic wiring. You've got your different gauges here, and you can strip the wires, and then you got to check and you can smoosh the connectors in. So you put them in there. So this I think runs about, I don't know, you can get a cheap one, maybe $10 or something. This one here, this end crimper, I think on Amazon in Japan was about 15 1500 yen, about 1,500 yen. And so about, I don't know how much that is, about maybe $20 or something. And the same for this. This is about 1,800 yen. There's maybe another $20. So, yeah, those are the things you don't need, but maybe make your wiring look a little bit prettier. You do get your wiring harness cable wrappy thing over here. Once you get all your wiring done, then you can start printing out stuff. And you can start printing out like frames or better cases for your ramps board and stuff like that. This is some frame case that I made and printed out. And because the one I got had the fan on top, and I wanted the fan on the side blowing across, and so I had easier access to the wires, where I could just pull out stuff and twist stuff without having to take the whole thing off. And so yeah, you can make your own stuff. That's the great thing about 3D printing. So yeah, if there are any questions, I think I answered everything about the wiring. DRV8825s. Oh, these are swappable for the A4988s. Just swap them out, and remember the potentiometers are going the other way. Just leave the stepper motors just the way they are right now, and also leave the jumpers. So underneath here there are a bunch of jumpers, and the full jumper set on the green ones, on these, it's 16 times micro stepping. But full jumpers on these DRV88s using the same jumpers is 32. So after you get all that done, if you swap to the DRV88s, you're going to have to change the settings in your in the firmware and re-upload it to your Arduino. And yeah, oh man, that's gonna be another video. Or I can just add it onto this. Sure, it's gonna be 1 hour long video on wiring for this thing. So, and I'm sitting Seiza for how long has it been? So my Arduino on my Flying Bear P902, when I got it in November of 2016, did not allow me to upload Arduino sketches onto that Arduino if I was using the latest version of the Arduino IDE. So I had to use, but it did let me upload sketches using Arduino 1.06, I think, or 1.03, I think, the default. And you can find this the default Marlin Arduino sketch on Thingiverse, and it will, if you're using like the default like 1.06 or 1.0 the old Arduino, then you can upload. But if you want to buy a new Arduino, like a genuine Arduino, that's going to cost you about $10 extra, and you can upload all the new stuff to that one. So this one is actually running, this Flying Bear is running on a official Arduino, which I can upload to using the newer sketches. So that's something to keep in mind. Once again, my Flying Bear, bought back in November of 2016, used Chinese knockoff Arduino, which didn't allow me to upload the new stuff. But using that same sketch, I could upload to an official Arduino. I don't know what that is. I don't know what that means. But I don't know, something in there that didn't allow me. But once I uninstalled and reinstalled the old Arduino environment, then I could upload. So I could actually upload the Diamond Hot End Marlin firmware onto this old Arduino here, Chinese knockoff, because it was using the 1.06 environment. So you can upload the old Flying Bear default firmware onto this thing if you're using the old environment too. So it still works. You can upload it, but it doesn't. The one that I got doesn't work with the new 1.8. So that's something to think about. Alright, so I don't know what else I can tell you. Make sure all your wires are connected properly. Yeah, don't lick anything that you're not supposed to lick. You lick everything that you're supposed to lick or that you want to lick, and then people will allow you to lick. And you won't get in trouble for it. Maybe some people are like, hey, why don't you lick this thing? And you're like, alright. And then maybe you'll get, you know what I'm saying? So do all that. And yeah, have a nice day. Have fun printing. Next video will be talking about the bed. And I don't think I'll go so long as this one. But yeah, a couple of cheap things to buy for the bed. Total price of getting all this stuff done. If you're going to rebuild if you're going to get a whole new set of drivers on here, that's $10. If you're going to get the voltage multimeter, that's about maybe $30. Or you can get a cheaper one or a pawn shop. So to get the voltage controller, the stepper motor driver voltage set at 70% what they're supposed to be set at for safety margins, you're looking at maybe $30, maybe $40 if you get new drivers, something like that. And yeah, that's about it. So a little bit of extra money, and you'll get it just, you know, at the right amount of power. Alright guys, and safety, also safety, and another $1.50 for those little trippers or something like that, fuses and stuff like that. So remember to get that stuff too. You don't want to burn on your house. Alright guys, talk to you guys later. Kanpai. Bye bye.